UK, right? And so we're just southeast of Bristol, southeast, right? Southwest of Bristol. And our host today is Q5D. And so, Chase, we've had this discussion. You were in there, Nick. I don't know how much you've heard, but we've established a company in Huntsville, Alabama called Molrix. And Molrix is working with Q5D on a partnership to help deliver advanced manufacturing wiring harness production, right? And Steve, who's our host today, is the CEO of the company, and he's going to share a little bit more. This is what we want to do is make sure you all understand the capabilities that they have. And today we're going to start with one of their baseline prototyping capabilities called the CY10, and Steve will talk about that. And then tomorrow we want to graduate and show you their big machine and some of the stuff they're doing for the automotive industry. We think that this capability directly aligns with what the requirements are of the Army to move forward in the production of hundreds of thousands of drones per year. And the way that they're laying wire right now and how they can do this in a precision manner to support UAS specifically, we're very excited. And to that point, with me today is Ellis Smith, and he's a program manager from University of Alabama in Huntsville. And University of Alabama in Huntsville has a laboratory that does prototype development of UAS. And Ellis has been running this program from them, and they have developed UAS. And he said right now that it's taking them about a day to a day and a half, maybe even 2 days, on a small drone just to create the wiring harness. What we hope to discover is how we can accelerate that speed and process, and then how we can bring some of these capabilities to what AMC's intending to do and what we intend to do across the Army as we elevate or advance our capabilities from producing 120,000 drones next year to over 1 million in 2030. And so we're really excited that Steve's offered to host us today, and I want to let him talk a little bit about Q5D, and then we're going to roll straight into Martin and the demo.
Okay, let me hand you over.
Yes, sir.
You can be cameraman.
I love it.
Okay, so yeah, thank you for joining us today. So Q5D, small company, venture capital backed, about 30 people just currently. We've got our first venture backing around 5 years ago, and have just closed our A series round, which has enabled us to grow to the kind of 30 people size. We released our first product, the one I'm showing here, a kind of an MVP, a small MVP, which we call the CY10. We launched that in 2023, primarily to stimulate the market and start the product management process. So in other words, enabling us to have meaningful discussions with various customers, largely across the automotive sector at the moment, and then of course moving into the defense sector, largely with Lockheed Martin. So they're a big investor in the company. And then just starting to talk and to introduce Simon here, who's with us, is our CMO. He's starting to get contacts now in the industrial, electrical, and consumer electrical market as well. So we're still at an early stage. Today we were demonstrating to a large automotive OEM on our larger machine, which we're going to show for any of you who are going to join tomorrow, which we call the SQ25. That's large enough to put whole car parts in. So that's the one that's more developed for manufacturing processes. This little machine we're showing today, it could be adapted for manufacturing purposes, and it is the one probably that UAH will take to demonstrate the wiring harnesses you might need for small Class 1 and Class 2 drones. But it really is a development machine, a machine that we use to develop the processes and the ways that you can use an adaptable machine like this to make wiring harnesses. And before we get into it, there are sort of 2 ways that we make wiring harnesses. One is to take a component, so that could be the shell of an unmanned aerial vehicle or a roof lining of a car, and then glue wires down onto that surface, and you'll see that process tomorrow. Or the other one is to laminate wires, to create wiring harnesses, and you'll see that's what you're going to see now, to create wiring harnesses that are encapsulated in some kind of tape, and then terminations put on the end. So it's a freestanding wiring harness that you can install into a vehicle or a drone in a kind of traditional hand way. So I'm going to hand over to Martin now, who's going to give you kind of a run through of how the machine can make this kind of
Can
wiring.
you talk about these other two wiring harnesses, Steve?
Well, they're essentially identical, but they're using different materials for for the lamination. So this one is a clear plastic one, which originally was the one that Tesla wanted us to make, although they kind of disappeared for the moment. It's kind of inflexible but stiff, so you can bend it into a certain shape and it'll hold that kind of shape. This one has got a hybrid. So let's go this one. This one is full what they call tether tape, which is a really highly flexible flock material, plastic flock. And that is very close to the kind of wire wrap that you might put on a traditional wiring harness. And this one is a kind of a monster hybrid, which has got the PET plastic on one side and a tether tape on the other, just so you can see the wires inside. These are very simple harnesses with these kind of terminations on the end, which I don't know how much detail you want to go into. It's what they call an installation displacement connector, the type that we like to use for full automation. And we're working with various companies to manufacture these at scale. And we're just got prototypes at the moment of this style of connector. So they can plug into standard type connectors, MCON type connectors, but inside them they're a different style that we can fully automate. You can also put in little features here so that you can have the kind of tree type connectors to be able to plug it into the connector, or you can glue them into the surface, whichever way you like to install them. But you're going to see one of these being manufactured now. So let's hand over to Martin.
Thank you.
And he can take you through the process.
I've actually had some good luck with the test tape.
Oh, good.
We're going to do the tape today.
Okay.
So, if you're ready, I'll.
Yeah.
Go.
You talk just a little bit about the software and the load of it, Martin. You have the design already loaded.
Yeah. I loaded the program before we got here. I've run a few tests on it, and everything's been going well. So I'm very hopeful.
So we have a CAD CAM system. It was done some time ago, and Martin's using that CAD CAM system. So that can take a computer-aided design, from any program really. We load that into our computer-aided manufacturing process, and that takes the user through a process which creates all the code which drives the robotics. Right. That's a key product that we sell alongside the machine to help customers be able to design the product, automate the creation of the code that drives the robotics. So without that, it's quite a long and tedious and complex process.
Yes.
But with it, it's relatively quick. It's still at an early stage of development, sort of alpha beta stage really, but it is something that we will be able to train you guys on. It'll be developed for the next year or so. So it goes out.
So adjusting shapes and lengths of wiring harnesses is not.
No, I mean, I put some time aside for a day or something like that.
Yeah, but if a form factor of the battery, if our manufacturer just did something different this year as opposed to last year, and I have a little bit different, that's not a.
It depends on how big an adjustment you make. Anything from locally editing code, just take a bit of length out to rerunning a bit of the CAD.
Hey, Pat, we're having trouble with audio. Maybe we can get a little closer.
Okay.
I'm sorry.
I'm closer to Simon now.
Okay, sorry.
Maybe it's the English versus English.
No, it's okay.
So thank you. I understand that what I was looking for is exactly what you told me, that it's dependent, but should be achievable without having to rewrite an entire program.
Think of it this way: it's no different to the exercise of dealing with product change in a CNC machining station. It's a subtractive one. Nobody thinks about that. Nobody second thinks that, right? Because it's just either I've got to change the CAD or I can make a local adjustment. But these machines are set up exactly the same way. It's the same thing. So if you get a change, a big change, yes, you're going to be doing some redrawing, but you might not be starting completely from scratch. If you've got a really small change, you can do it like that. I just wanted to, if the sample wasn't to hand when Steve was showing the others, I wanted to show that, which is one of the other ways in which the machine can be used, which might be interesting for UAS because it's integrating the wiring into a complex 3D surface. This one's concave, but it could be convex instead. So if you're making something which kind of clamshells together, for example, you could maybe add the tracks directly into the part and secure them into the actual structure of the UAS before you then close it. So that was all that was. I just wanted to show that because it's a little bit
That's
different.
fantastic.
All right, Martin.
Go for it.
All right, let's go.
Martin, can you kind of explain what's going on right there with it coming off the spool
Yeah.
and the layout?
We have extruded details in the G code, and on the reel we have a gearbox that goes through the end nozzle, which will then feed the wire at the speed you've chosen in the CAM software. And we're just using the traps and hold the wire securely in place.
And can you talk about the calibration that's going on as it lays the wire?
There's no calibration as such. It's all
Okay.
been inputted into the CAD/CAM software.
But the machine is built to be built relatively cost effectively. So it's not a machine high accuracy bed. It's a welded steel frame. A very rigid welded steel frame, but nonetheless it comes with inherent inaccuracy. We have a calibration routine, which we do when we build the machine up, that measures, and we can repeat during the life of the machine, that measures all those inaccuracies, and then the software compensates them. So what we need in order to be able to manufacture this is simply to know where the part is. Now, we either know that, in this instance, we know that because we have a fixture and we have a locating pin in the center. The machine knows where the locating pin is, so therefore it knows where the fixture is. Tomorrow, when we show you the SQ25, you'll see that on that machine, a part finding system based on a laser, which uses little fiducial marks, and it picks the laser, finds the fiducial marks, then knows what the position of each of the components to be wired actually is, which means you can style stuff which is not made all that accurately, and you don't buy an expensive fixture. So it's really
Wow.
Hey, Chase, as we're printing right now, I hope you were able to hear Simon's explanation. Did you have any questions as we kind of go through the print job?
Yeah. So just a couple, and I did hear the explanation. It's actually a lot faster than I expected. So two initial questions. What's the max wire gauge that you can print, and the wire reel that you're feeding through the machine? Is it a special wire that needs to be sole sourced, or can we throw any kind of wire on there?
So you can throw anything that's round and isn't bigger than 4 millimeters outside diameter at it. Anything round up to 4 millimeters diameter, it'll print it. So whatever wire you want to use. And then in terms of length, so at the moment we're running with a few hundred meters on a reel that's on it. The machines are configured so that we can continuously feed wire from outside. So you could have several thousand meters of wire on a big drum outside, and it will pull down through the arm in the center and out through the.
Oh,
How sensitive to atmospherics is the process?
Not
Perfect.
I mean, I would say, let me qualify that slightly. We've never had an issue. We probably haven't done enough different things to be certain there's no effect. But what I would say at the moment is that if your temperature is stable across a 10 Celsius range, pick whatever range you like, it's going to work. So if your materials work at that temperature, the likelihood is the machine will too. And as long as you keep that range somewhat even, you shouldn't have problems.
It's only a calibration. So if you go outside that range, you might just want to recalibrate the machine. But we haven't really tried that.
How long is the calibration process in that instance?
Couple of minutes.
Oh, wow, okay.
Yeah, not long. So you might end up having to do a bigger recalibration effort if it's really knocked itself out somehow. But it's about 2 minutes to run a daily check, which puts the sync back into it. And we don't sync even daily, do we? We do a calibration check.
Yeah.
Every few months, maybe.
Yeah. The only time we have to do a major one is when your operator drives it into a wall or the ground.
And when Martin snapped the tip off.
I mean, it's kind of like the CNC machines I used to use. This, unless you have a mock, calibration is pretty good on.
So I ask really because where I see a machine going in our facilities, the building that we're in, and nobody heard this from me, but the building that we're in at UAH is the second oldest on campus. So it comes with some delicacies in its HVAC system that require a lot of maintenance, and sometimes it just fails. So if we go from, we go from like 74 degrees Fahrenheit to 90.
I don't think give a problem.
Yeah.
And there's no air conditioning in this room, and it was warm in the summer for us anyway, with 30 degrees outside. And there was only passive cooling in the sense that the doors open. We didn't have any calibration issues, didn't have any in the things that the game just ran. So I know the other question Chase asked was about speed.
Yeah.
So
I've actually got a demo program to run max speed, if you want to see it.
Go ahead.
Go
Hey,
ahead.
Chase, you all right with that?
Yeah, I'm all good here.
Okay.
Hey, and while we transition over, can you give me the stats real quick on that? Is that like a 7 conductor harness?
something like that, yeah.
Okay.
So that wasn't trying to put wire down there because it probably would have just pulled off. But that's the kind of speed the machine moves at.
Yeah.
The problem, speed is almost entirely dependent on the materials, not the machine. So if the materials are appropriate and the shape of the part is appropriate, you can lay wire at 1.2 meters per second. But you broadly have to be going in a straight line, and it broadly has to be reasonably flat. If you start introducing topography and curves and things, you will slow that down a bit. And then it's just a question of where you get to. But as you'll see with the SQ25 lane wires, it comes around the side of the headliner, does 2 meters of wire, and it looks pretty quick now. But it's actually currently running at about 1/20th of its potential speed. Mostly because otherwise we're going to run out of headliners, because as we're working on the process, we are occasionally crashing into things, and we only have a certain number of things that we substrates at the moment.
Yeah.
So that's all just process optimization though, but the inherent speed is without question a lot faster than we've just witnessed.
So the demo that you made that, how long is that interval? You know?
Funny enough, quite
In a half?
yeah, maybe.
It was much faster than I thought.
But as you were saying earlier about making certain changes, that was written in what?
We're having a little trouble hearing again. Sorry.
Yeah, he was just saying that the whole thing was written in about 20 or 30 seconds. So the speed of this thing in the print job was probably a minute and a half. And so we were just talking about speed, and Simon says that's well under where they want to be. And you can see how fast the machine can move. And so it's going to be in the future all about how fast you can lay it down on topography or whether or not it's going to be a straight line.
And, you know, to a certain extent, with the bigger wires, if you're running really quickly with the bigger wires, you kind of get this wave effect where we'll need to work on as well, where the wire is trying to return to, it's got a certain memory,
Mhm.
and as it tries to return, you get a little bit of a lift behind it. So depending on this choice of substrate, the choice of adhesive, if you're using adhesive or the method of capturing that wire, if you're only anchoring it at the ends, that's not going to matter. So, you know, if you're only anchoring, we've got a couple of projects coming up where that's going to be the case. We're really only going to anchor it at its outer ends and not in between those 2 points. That could go in any shape at like, you know, that's just going to be a meter per second the whole way. So just as well, it's quite a big wiring harness. But
There's two parts of the process though. So one is laying the wire, and then the second part is doing the terminations, the plugs on the end. And so quite a lot of the time taken will be determined by the choice that you make, the customer makes, around the termination type.
Yeah.
So some are much, much faster, like some installation displacement connectors, it's a second just to do it. If you choose a complex crimp and a really complex mil spec housing, that's many, many minutes. And so a lot of the choices around speed are going to be choices around choice of termination.
Yeah.
But the speed you can achieve is still potentially much greater than either manual build of the harness or hiring a company that's what they do for a living.
Yeah. You can do it yourself.
Yeah.
So none of those problems with you know.
And then, you know, as long as it was drawn correctly in the program,
Yeah.
you know that it's going to turn out.
Yeah.
With
Once
everything pinned out properly.
Once you've tested the first harness that comes off, then you've got a pretty good, everything's going to be exactly the same afterwards. You've made a mistake on that first one, you'll make a mistake on all of them. So you might still want to do some testing, but they're all going to be identical after the first one you've made.
Yeah. And I think that does, and we've even had this conversation with the automotive industry, where currently they do 100% end of line testing. That they're getting their heads around the idea that I don't really need that, because if I do 1 in 1,000 or something, functional testing, that's good enough, because otherwise I know exactly what the machine made.
Yeah.
I mean, you know, if you really want a true digital twin, you could have a true digital twin here, because you would have the drawing of what you were going to make, the part, and then as the machine operates, you can capture the data of the path that it's followed.
That's right.
And therefore you know exactly what was built, and you know what any differences were.
So that's what we're working on now, right? Is we're working to qualify a part once, qualify a process continuously.
Yeah.
So you don't have to requalify each unique and individual part. We're controlling for the process.
Yeah.
Yeah.
And that's what the Army is going to end up doing. That's how they'll do it for certification going forward.
Well, I think we're done down here.
Okay.
Thank you, Martin.
Thank you, Mark.
We can go upstairs to the meeting room and
Very
show a
good.
couple of slides if you like.
Very good.
So perhaps we turn the camera off so they don't get
All right.
motion sickness. We wander upstairs, and then we can reconvene up there.
Okay. Well,
Cheers, Martin. Thank you very much.
yes, sir.
Very good. Yeah, they're still here, aren't they? Hi, Daniel. I don't know why it's not showing up on the screen. Why is it showing up?
There you go.
Let's stop out there. But I am on the meeting. It's just not showing up on our screen here. But that's what the problem is. Then that's not too much of a problem. Okay. Can you guys hear us okay?
We can.
Good. Good. Let me just see if I can get this working on our screen here. If it's not, I don't think it's a disaster.
You can share it though in Teams.
I can share it here, but the guys in the room can't see it at the moment.
It's okay.
But if so,
We can easily slide
Look over your shoulder.
and listen intently.
yeah. I mean, it was working on the screen a second.
It was.
But I don't know why it's decided to do that now. There we go.
Yep, we're good.
Good. Right. Let me so two various things I could show. So yeah. It's our standard customer presentation. Maybe that's the first one. Or I could show the stuff we were showing today to our OEM customer, the SQ25, which I think is the most relevant. To show the slides I was showing a few minutes ago, or just the general customer introduction.
Yeah, I think if we do the general customer introduction today, tomorrow we show that with the SQ25.
Let's do that.
Okay. Because Chase can help us set conditions with Rob, Chase, if you don't mind. And that way we'll get a little bit more detailed on the SQ25 tomorrow.
Yeah, no problem. Hey, I had a couple additional follow-ups. So if I understand correct, what we just saw was conductor layout. Will it bundle, or are we stuck with a flat pattern? And I assume the follow-on process would be to do the overmold jacket after what we just experienced.
Yeah, so we use a lamination process rather than a wire wrap. Wire wrap you really can't do it in that kind of way. So we use the same materials, Tessa tape or whatever you're used to in terms of the material to contain it. We can layer it up, so you can't create a bundle in the way that you might, so where the wires roll around each other. But we could create a layer. So you could lay down, say, 5 wires, another 5 wires on top of that, another 2 layer. So you could build up a structure. So we've done that plenty of times, and then laminate over the top of it to create a protection layer if that's what you want. But yeah, we don't wrap, because no one's really managed to automate that on a complex shaped wiring harness yet.
I think if we show tomorrow, if we show the headliner that we were looking at before the call,
yeah,
that would illustrate to them, I think, what you're talking about.
Okay.
Yeah, we'll show you that tomorrow, Chase.
Okay. Yeah, and I mean, to be honest with you, bundling is a real pain in the butt anyway.
Yes.
So for some, go ahead.
Sorry, go.
Yeah, for some of our soldier worn cables connecting to sensors and things like that, we've actually moved toward a flat pattern multi-conductor cable that we purchase outside. This would kind of be ideal for that sense, and as well as running in vehicles and things like that. I was just rather curious about bundling capability, but flat patterns, you probably end up saving space anyway.
You do,
and then just
yeah. I mean, the reason the reason we did it is for. The reason we did it was for the headliners, the headliner people. They have fights with their marketing department and other departments over the 3 millimeters of the headlight, and so the flat, they really like the flat ones. But it really just did custom to customer. We can sort of develop it in whichever way is appropriate.
And Chase, the other thing that we're really excited about and what we see with Q5D is the way they lay this. We can get to the point that wiring harnesses aren't going to be a supply shortage. That's what we should start thinking through, is how should we be thinking about redesigning our wiring harnesses to make them, one, plug and play, Two, attritable and replaceable very easily. In other words, instead of thinking that we're going to have this big round, 1.5-inch cable pipe laying across a vehicle or a UAS or anything else, we can start looking at these and how they can work inside of our current, but we got to be willing to change our thought process on what it should look like.
Yep, 100%. Couldn't agree more. Last question I had, and maybe you cover this. What's the limitation on print space?
Oh, yeah, there are some. So, I mean, we like convex surfaces, but we can do concave to a certain diameter. I can't, off the top of my head, give you that, but it's sort of like 100 millimeter sort of diameter half shell we could probably do, but we couldn't put it inside a pipe. That just would not work. So when we've had to do things like that, you either do it as a clamshell and stick the two halves of the clamshell together, or you create a skeleton and build the wires onto that skeleton and slide it inside the pipe. So obviously when we're working with Lockheed's missile defense people, that's the kind of thing we have to do.
Gotcha. And then if I have a vehicle harness, that runs from the front to the back of a HEMTT, very large, heavy tactical vehicle. Do I need to do things like loop my harness around in S patterns in order to gain that full length of the vehicle?
No, you'll see the SQ-25 tomorrow. So that's 2.5 meters in one dimension and 1.5 meters in one dimension. The 1.5 meter dimension is open. And so the plan is from there is to put that in to create another axis in there. So put a conveyor belt in there. So it's basically infinite in that dimension. So you'll have infinity by 2.5 meters as as the size of harness that you can make.
Gotcha. Okay.
So the little SQ-25 you're seeing up on the screen, I mean, that is a machine. I think it is probably suitable for the Class 1 and Class 2 drones, but not much more than that, really.
Right, and I think either sliding a scaffold or skeleton inside the tube to house the wiring harness, or manually placing the harness and adhering it somehow at our scale of production is completely acceptable.
Yeah.
Because really, the assembly of the drone itself doesn't take that long. It's for us, the wiring harness is the only bottleneck.
Well, when this is fully automated, we're kind of expecting it to run overnight. So you could just run out, you can run out.
Capacity 24 hours.
Just run it a few hundred overnight, and then they're all ready for your assembly in the morning.
But I also think that Ellis might have some wiring harnesses that he needs to have built, but David might have some wiring harnesses he needs to have built. So time on the machine is going to be contested.
Yes. Yeah, exactly. I mean, but the whole point of our machine really is it's reconfigurable. So obviously, if you have a completely different harness, if it's using the same wires, then it's just a change of software, and it'll just do it. But you might need to reload a whole bunch of new wires on there, or a different set of terminations, depending on the change you're making. Right. In principle, it's quite quick to change over from one harness to the next. Anyway, so
hey, that brings up another good question. Is it one standard reel? So like one typical set of wire gauge per run, or can you do multiple reels? Say I need to run a couple 20 gauge wires, and then I need to change out to a couple 26 gauge wires. Is that all possible in one programmed operation?
So little machine here has 3 stations, so 3 different heads. So there's not very many changes you can make, but each one could have a different wire gauge preloaded. On the SQ-25, the big one, then there's much more possibility. In fact, ultimately we'll probably have a carousel, so it will just offer up the end effector that you require, and that end effector will have that particular wire type loaded. So So at the moment on the little tiny machine here, you can have 3 different wire types preloaded, and on the SQ-25 it will be many more times than that.
Awesome. Yeah. So just like a tool changer on a CNC.
Exactly that. That's exactly what it'll look like.
Okay.
In fact, we use the very similar technology to do that tool change.
Awesome.
All right, so this is us. We're based in Bristol. I'm guessing you kind of know where we are. Bristol is an aerospace cluster. I think it's one of the biggest aerospace clusters in Western Europe, actually. So you know, everybody's here, from BAE Systems through Leonardo to GSK to, well, basically everyone, Thales, a lot. So it's a great place to be for us to steal good engineers, which we do a lot. And you know, there are also some good customers close to us as well. We're venture backed. It says 25 employees, so that was correct in July. We're now 30, so we just finished a funding round. And as you can see, Lockheed Martin and Chrysalix are our two biggest investors. So we get about 60% of our money from the US in terms of investment, 30% from the UK, and now one from Japan as well. So, so yeah, strongly invested in the US, or strongly invested in the US is strongly invested in us. Is probably more. Second point. So this is obviously, I mean, you're all familiar with this. This is the kind of wiring harness process at the moment from Miyazaki, one of the people we talked to actually. So I think this will be highly familiar to Henry Ford. Nothing much has changed in 120 years. And I think you're all aware of the problems that it engenders. So one is how labor intensive it is and how expensive it is, how error prone it is, particularly when you have to employ you know, low paid workers. In the automotive industry, but not in the defense industry, it's all pushed out to Morocco or to Algiers or in America, in Mexico. I think for the defense industry, you use a lot of, so Lockheed Martin use a lot of small companies around the US who are finding it increasingly difficult to recruit. And the supply chains have proven to be highly fragile. You know, not just from COVID, but wars. The European manufacturers all used to be based in Ukraine, and that was a massive scramble to get them all out and into North Africa. And everyone has been scarred through the defense industry and through the automotive industry likewise about how difficult these supply chains are. So you've seen the machine on the left there, which is fading out, which is our hardware. That's the platform. It's a 5-axis platform. Nothing that special about it. It uses linear motors so that we can drive it very fast. In the SQ25, it accelerates at 10 meters per second. And then, so, you know, we had two sets of platforms, the large platform, which we call the SQ25, the small platform you've just seen, the CY10, and then a whole suite of end effectors that lay different wire types, can lay glue, can do terminations of different types, et cetera, et cetera. So you will get a platform and then a suite of end effectors that are tailored to the processes that you want for your particular job. We then have a whole set of software. Obviously, there's software embedded in the machine. You know, this intelligent firmware that interprets the code, the robotics code. But then we have a suite of CAD/CAM software based on Siemens NX, and it's based on 5-axis additive software, which is all very new. Even for Siemens, it's kind of a beta product. We've written a whole bunch of post processors and digital twins, which can convert that 5-axis additive software to be able to add glue or wires onto the surface of a product. So that's the second product. And then the third product are the support and services. So we run a technical assessment center in the UK, which enables customers to come and try things out. So we do proof of concept work or low rate manufacture. I mean, we're kind of anticipating that UAH is going to be like that for us in the US. They're going to be working on a specific part of what we do, but effectively they're going to be a service for the US defense industry. And then, of course, we run service and support teams. In this case, Tritium and Morux are going to be part of that service and support teams. They're going to be the first line support. We'll be the second line support for that. So that's our third product line. So that's what we sell. And these are the kind of things we make. So you've seen the freestanding harnesses down there, different types of wraps, different types of termination types. And that enables you to create a wiring harness, which is a bit like an existing wiring harness. It's not exactly the same. There are some differences, but you can treat it a bit like a normal wiring harness, which then an operator can hand install into your product. Where possible, we like to use something where we can add the wire down onto a three-dimensional surface, and you'll see that process tomorrow. So at the moment, we're working mostly on the roof linings of vehicles. So we work with Jaguar Land Rover, General Motors, Toyota, companies like that. And that uses glue to stick the wires down directly onto a surface. The benefit of that is that it creates a component which automates end to end. So there is one handmade process, and that's loading that component onto the main. Well, it doesn't even, that could be done robotically in principle as well. So in that second process enables pretty much full automation if you can use it. And then the last part, and this is a product we'll be launching next year, is printed electronics. It uses the same platform, but incorporates spray heads and a laser. So you can metallize a surface with a spray and then use a laser to very quickly etch. It could be a PCB board. In this case, you're seeing a frequency selective shield, which is a prototype for the F-35 radar filtration. It could be antenna. It could be a capacitive touch surface. It's much faster than any other process on the market, and it can use pretty much any substrate. So in this case, the benefit is that it can be put on peaks and fakes, those very high-end polymers that the aerospace industry like to use. So so separate out the products and the processes. We do own intellectual property in quite a lot of these processes, but we don't need to. So if a customer develops their own process using our machine, they can patent and own that themselves if they want. Yeah. And I know that's something that Molerex and 3D and the UAH are quite keen to do.
Yeah, and I mean, that was a question that I wanted to ask. There arises an instance where we want your machine to do something it currently can't do, but it's not because of limitations of the machine, it's we don't have the right end effector. We collaborate with you, or we come up with a design on our own.
We will want to own that. Okay. So anything about the machine and software, we will be really rigorous about owning that. Yeah. But actually the strongest patents are the patents around this. So for example, patents around how the hell do you lay down a twisted pair and terminate it correctly? We file patents on that, but we don't need to. I mean, they are the strongest patents. The patents around and the trademarks around and design patents around the machines, they're not very strong patents anyway, although we own them. And we want to continue to own anything around our software and hardware. But if you develop, say, a process which enables you to put wires down in a slightly different way, or trap them in a different way, or use a different adhesive, or whatever it might be, that's yours. Right. Patent it. Right. It's a strong patent because you can immediately see if somebody's infringing you, and it's all yours. But no, we will be very strict about owning anything around the machine.
And we've had those discussions, and so, Chase, for you and for the UAH team, I mean, right, this machine is coming from Q5D. Anything related to that machine, you guys have anything on that manufacturing process side, as we develop those out, the machine can do it, then that's going to be additive over here that we'll own, but we are very clear on who owns that machine capabilities.
To give you an example, like you can't see it at the moment, so I'll show you later. But the terminations on the thing that you just saw that made downstairs, the ones that we're using at the moment are prototypes from TE Connectivity. So we're working with TE Connectivity and Kyocera. We've given them some designs, which they are now, this is TE, which they're now making prototypes of, and we won't need to own that because we just want that out in the market. Right. We want them selling the termination types that are adaptable for our machine.
Part of that supply package.
And we will then have an end effector which is suitable for that use. So yeah, products, we got, you've seen the CY10, which is our little machine, and you can see it sort of doing a sort of an early prototype of the flat wiring harness that you saw being manufactured earlier. The SQ25, this is when it first arrived a little while ago. It's kind of moved on quite a lot, but since then there's a lot more parts to it. Big machine, you can see it's got a volume of 2.5 meters by 1.5, and the 1.5 side, as I said before, you could imagine a conveyor belt going through that, a conveyor platform, and so you could make that as long as you like. So if you've got an aircraft which is 100 meters long, you could make a wiring harness 100 meters long if you wanted to.
I didn't even say that.
So those are the platforms. They got full 5 axes of motion so that they can come in and address the component that you want from any angle you need. Then we have a whole suite of end effectors. These are some of the prototype ones, and they can lay down wire of anything from at the moment we can do about 0.3 millimeters diameter, outside diameter, up to about 4 millimeters outside diameter. We've had requests outside that, and that's a process that we would work on if a customer asks for it. It can lay bare, insulated, or twisted pair, multiple different types of insulation type. If it's not an insulation type we've tried before, we will have a go and work with you to develop it. And we've even done work on micro coaxial cable as well.
Steve, can you talk? I found it interesting. We talked about EMI protection, wire identification, everything else. You're using orange wire, but you have a specific reason as to why you use orange wire right now.
We use orange wire because that's our color. So
Right,
it's all in our branding. But you can use whatever color you like, although we do not like to use different colors.
right.
So ideally, we would like to use a labeling machine. So in other words, you take a machine that would actually put down a number or a barcode onto the wire prior to being loaded into our machine, and so they're all the same wire color,
Right.
but they're all labeled separately.
So we have traceability on that specific wire to understand any quality issues or challenges we may have.
Yeah,
We don't necessarily have to have 6 different wire colors.
we would prefer not to. If you need it, we will do it, but it's really clunky.
You've got to ask the question, why do you need the colour?
Yeah.
And if you're not hand assembling a wiring harness, it isn't because you've got to have colour in order to get the right connection in the right place, right? Because the machine's going to do that then. If it's about maintenance, so I don't know how these drones will be maintained, but there's everything from they won't be maintained,
Right.
to if they need to be field maintained, you're just going to change the whole damn wire from connector to connector, in which case, theoretically, all you need to have is a number on each end.
Yeah.
And that could be in the connector housing. And so you know you're going to pin 32 at this end and pin 26 at that end, and you're just going to take that wire out completely and replace it with another one.
Right.
So I think thinking through why you want it marked is a good thing. You can have any colour you like. So if you want to have 6 different colours on the same wire, on the same size, that's fine. It just means effectively if you've got to do a change. So you've either got to change the reel or you've got to change the head. And depending on the volume you're doing, that's a penalty. It might be a penalty you're willing to take because you say, well, the value of these things is such that I don't care that I've got 6 end effectors. One with each
Or
colour
even
of
6
wire.
machines, one after the other,
Or
each
whatever,
doing
yeah.
a wire color.
But
Hey,
you might say,
and so Simon, I did that a little bit for effect because Chase, as we start going through this, there's going to be certain mil specs that are going to pop up and we're going to say, oh my gosh, we can't do it. What we want to do is take this, open industry approach and say, why are we challenging the mil spec? Why are we thinking about this in a way that we have to do it the way it was outlined in 1968? We need to take the gloves off a little bit and figure out how we can take new technology and fully integrate it into our processes.
Well, I think there's some real benefits to not changing the wire color for anti-tamper and, for folks to not be able to easily figure out what's my wiring harness doing.
yeah, what's this actually do? You capture a drone and you take it apart and you go, oh, it's just all orange wires. Shit, I don't know
What do I do now?
What do I do?
Which is hot, which is not. Yeah.
It's just a little bit more difficult. And actually, the guys who've just walked out the door, the other visitors, they have gone from multicolored wires in their vehicles to single color wires precisely so to make them tamper proof. So you have to have the maintenance manual or you can't maintain it.
Yeah. Chase, any questions or comments on that point?
No, I completely agree. Most of the vehicle harness and weapon system harnesses we see are just using your standard white, gauge wire. Specific mil specs. Agree with your comment. We should be pushing different technologies, up against some of the program offices to change the design thinking. That would make things much easier for us. But yeah, just completely agree. The only other question I had is, are you able to share these slides?
Yes. Yeah, we can send them across.
Hey, Pat.
Yes, sir.
Hey, so I missed the first few minutes of the conversation. I'm going to be in and out today because I've got about 500 competing requirements. But on your conversation, you talked about challenging standards that are in mil spec and requirements. I think General Mohan is very open to that, right? I think in his new authorities to qualify parts for the Army that was directed to him from the Secretary of the Army, he is interested to figure out how we get into this space for advanced manufacturing of wiring harnesses so that he can qualify them. Let folks like Toby Hanna then take that back to a item manager or a program manager. Let them then put them into as a substitutable NIN or item for them, so we can move past that hurdle you're talking about. We're doing the same thing with NIAR right now, and some other folks on the additive manufacturing side for metals.
Yep.
I think we have to move into that space for this as well. And the next space for that is printed circuit card boards that Chase and the team will be doing there at Toby Hanna as well. That's exactly where General Mohan's thinking, and that's where we're going to drive this conversation to from AMC.
Thank you. Appreciate it, Carl Crawford.
Excellent. Also, we have end effectors which are able to lay down glues or even polymers if you want to adhere wires to surfaces or to encapsulate them for additional protection. And of course, we have end effectors which can do the terminations of different types.
And a very wide range, everything from hot melt glue to peak.
Yeah, so I can lay those down. The software is an important part of our product line. So, I mean, in principle, you can use any CAD you like, but we can supply that as well if you want to. We use a base of Siemens NX. And then the computer-aided manufacturing software, again, based on a kind of a beta product from Siemens NX, which is 5-axis additive, which we then adapted using post-processors so that we can lay wires or glue down onto a complex three-dimensional geometry. So we can supply that, and it makes it really facile, really easy for you to go from a CAD design through to creating all the code you need to drive the robotics. And that's really quite important.
Is that a heat?
Yeah, don't worry, ignore that. That's an old video I should get rid of. When we got the call from a certain large UK OEM, automotive OEM, to say, can you do headliners? They kind of gaffer taped a process together to do that in about 3 weeks. Yeah.
It's okay. The glue was laying down, and because it's hot melt, it needed to get a reactivation. So that's what that was.
We don't use that anymore. Our engineers are very quick. So they managed to get this demonstration together in a matter of weeks. The printed electronics, which I kind of mentioned already, will launch this in January 21. So any of you who want to come and view that or come and visit it would be keen to see you. So it uses 2 heads. So it's the same platform, but 2 heads, one which can lay down a metal surface to metalize the surface, and then a laser which then can etch out whatever shape you like. So as I said, the shape you see there is a frequency selective shielding that we did. It was a customer who's trying to sell into Lockheed for making these frequency selective shieldings. But 3-dimensional personal PCB boards, capacitive sensors, RF shielding, embedded antenna, those are the kinds of things that this is designed for. And I don't know if you're familiar with the printed electronics world. We can get into detail about why it's so much better than existing processes. But we'll launch that as an early alpha product next year, and that means it will be available for use internally. So you can come and do proof of concept work on it.
And this is a simple way of stating what its key advantage is, that it can do everything that LDS does today by having nanoparticle loaded high cost polymers, but it can do all of that on a much bigger scale. So the CY10 is a meter diameter, half a meter tall build volume. You can do that processing, that electronics processing anywhere in that build volume.
Oh,
So very much larger than anything you'd see today.
On any substrate. So you do it on peaks and pakes, and it's fast and it's cheap and just as accurate. Okay, so processes, I think you've seen some of these already today. So what we can do, so we can create a freestanding wiring harness at the moment with whatever your favorite connector is on one end, whether it's a Molex or whatever you want. A mil spec if it has to be.
A cannon plug.
Yeah, we don't. I mean, it's incredibly slow, and we don't like it, but we can do it. And on the other end, it would have an insulation displacement connector on a splice box. For those sitting in the room, it looks like that. And then it's all laminated to give a bit additional protection.
I think the applications that I'm looking at, and when I'm not necessarily building for big Army, when I'm building for a special operations customer, their requirements are not as stringent. So could I foresee using something like this in my air vehicle? Absolutely, yes. And, you know, I don't have to have specially soldered and crimped connectors.
Yeah.
But what I need is that rapid production capability with built-in QA/QC.
Then using this, and then, you know, the stuff I've told you about that we're doing with Lockheed to qualify that kind of thing for the defence sector, we would have to repeat because we don't have access to that data. But you know, adding a dot of resin on the top to make it
anti-intrusion.
Yeah, all possible, all automated.
So these two little items here.
Sorry guys, you can't see this online. Perhaps you can hold the app.
I might try holding it to the camera. But I don't know if that shows.
Maybe, I don't know.
So there's a couple of little prototype. They're an MCON automotive standard connector on one end, on the business end. The back end has been changed from being print and insert terminals to being terminals that are in there. They have an IDC built into them so the machine can load straight to them. So Steve was talking about, well, we can do legacy connectors, but there are also connectors coming quite rapidly now that are fully automatable. If you can shift to something like that, you're going to make transformational change in terms of speed. I mean, probably of the order of putting a crimp on the end and inserting it into a body is probably a 10 or 12 second job, regardless of how much we lean it out.
Yeah.
Right. So it's and you might get it down to 7 seconds, but the machines themselves are not all that fast. The sort of traditional wire handling, wire preparation machines. And then you've got to transverse over to the connection, you've got to put it in. If you move to a connector like this, effectively there's no break in the laying. Right, so you lay your wire, you're coming across, you pass it over the top of the thing, you then turn around and you're going back the other way. You could even have a separate arm coming along on another carriage, because we could have more than one carriage on our machine. The second carriage comes along and makes the connection. You're then down to each connection being made in the equivalent of about 1.5 seconds. So when you want volume, this is the way to go for sure.
Well, I appreciate that, you know, you guys have already thought about the different types of IDCs that we can use and how creative we can be, because I think that's going to be part of it. We come up with a stock that says, okay, here's our next 4 or 5 types that we would like to figure out, and whether you do it or we find a commercial vendor to do it.
Well, I mean, Kaisera or something like that would kill to do that for you. We would just go to one of these guys and say, we need this. This is the type we want. Can you do it? Can you test it? And then supply it.
And we already have good working relationships with Kaisera and with TE. So
and these are TE.
These are TE ones. The other ones that we've got in here are Kaisera ones. Either of those guys would be delighted to participate, I'm sure, and maybe both of them, because they each bring slightly different things to the party. So
okay. So that's the second one on the sort of going from left to right. So that has, you know, these IDC connectors on both ends, much quicker. And then what you'll see tomorrow on the SQ25 is laying wires down onto a 3-dimensional surface. And then the last one is combining those two bits together with a flying beam and a component. That's basically one corner of a headliner that we're making for multiple customers. I'm aware that we sort of haven't got so long left, so I'm going to sort of just rattle on through. So I'm not going to go through in massive detail. This is just looking at the first one of those in a bit more detail. So crimp style connectors on one end, IDCs on the other, laminated freestanding harness. This one here with the different type of fleece or foam or PET, whatever lamination you like. You can choose whatever you want, and then you can even put in those little fir tree type connectors to plug it into something if you want to. And then I'm going to skip through these. You can see basically what it is. It's got the termination box. It's got an IDC split box there, which is a distribution box, which then goes out to all the other modules within the headliner, and then a a freestanding wiring harness which is laminated, which goes down one of the pillars in the vehicle.
And maybe worth just saying that we can stick it on a laminate, we can glue it down, we can stick it in a channel.
Yep.
Or you don't have to do any of that stuff. You can just go from connector to connector and wrap it around a series of tool posts that are a bit like a board and make something that is akin to what you make by hand today. It's super flexible intentionally. It's just about, well, what design choices do you want to make? What's appropriate to the thing you're trying to make?
Fair enough. Print electronics, which were I sort of mentioned already. I'm not going to go into much more detail. It's capable of about 100 microns gap and track, so it's not like a semiconductor. It's not that kind of scale. It is made for electrical work, and that covers quite a large fraction of the industry. So come and see us on at the moment, 21st of January, I think it says. Dates also. All right. I think I'm going to stop there. The case study is a headliner, and you're going to see the headliner.
That's right.
In much more detail tomorrow. So in excruciating detail tomorrow. So you'll see that there. So I'm gonna stop there, and we can just chat.
Hey, so let me, I don't know if Colonel Crocker's still on, but James, if you're on, any questions for Steve or our team?
Hey, team, Colonel Crocker dropped off.
Okay. Hey, Chase, anything from you?
No, nothing here. I'm going to write this back brief up for Mr. Lanka and get it over to him today. So he's got some information walking into tomorrow's demo. Just the only ask is either through this chat or just shoot me an email, or the team an email with the slides. That would be excellent.
Hey, so Chase, you've gotten a version of these before. The challenge is going to be the size of the file, getting it through the .mil pipes.
Well, I can do a PDF version which won't have the
videos, right?
So I'll shoot that across straight after this meeting.
If if possible, I could drop you a DoD safe link, and you can upload the file to the safe.
If you want the full video, then we can do that.
Yeah, that's how.
And actually, you can do that a lot simpler over here than we do back home, because you can do it at off-peak times just by definition.
Right.
Yeah.
Fair enough.
Right.
Yeah.
So Chase, that'd be excellent, so we can get the full thing to Mr. Lanka, because we won't do this briefing tomorrow. We'll do the SQ-25 and a little bit different briefing that's going to get into a little bit more detail. But I think Mr. Lanka has a general idea. He doesn't have all those videos.
Right. And I think the videos are really what drives it home.
Yeah, well, the live demo does too.
Yeah,
I think
sure.
you agree with that. Yeah. Thanks, Chase. We appreciate you being here today. Hey, Van, anything from you before we close out for today?
No. The only thing I was going to go back and add earlier, that y'all kind of covered it very well, was the concept of modifying the production processes to take the most advantage of the automation, and y'all covered that well. So thank you.
Thank you, Van.
Excellent.
Yeah, thanks everybody very much. We appreciate it, and look forward to seeing some of you again tomorrow. Chase, you for sure, and I think probably everybody on this call now. But appreciate your time today. Thank you.
Cheers, everybody.
Thanks,
Bye.
everybody.
Thanks, everybody.
Bye-bye.
Thank you.
Out.